feed a 230-volt load from a 480Y/277-volt three-phase panel, given that the existing setup was for a 480-volt three-phase 50 amps sterilizer, and now you have a 230-volt 15 amps load, you'll need to take specific steps. Firstly, gather the required materials, which include a 230-volt step-down or drop-out transformer rated for at least 15 amps, a 230-volt branch circuit breaker rated for 15 amps, a 230-volt outlet and a corresponding cover plate, and appropriate wire connectors. Secondly, before starting any work, ensure the 480Y/277-volt three-phase panel is completely powered down and properly locked out and tied out to prevent any accidental energization during the process. This is critical for safety. Thirdly, securely mount the 230-volt step-down transformer in the designated space. Ensure it's appropriately positioned and fastened to a stable surface. Fourthly, wire the transformer by connecting the primary side, which is the 480-volt side, of the transformer to the 480Y/277-volt three-phase panel using the appropriate wire connectors. Ensure that the primary voltage and phase connections precisely match the transformer's specifications. Typically, this involves connecting the three phases A, B, and C, and possibly a neutral connection depending on the transformer design. Fifthly, install the 230-volt branch circuit breaker in the panel. Connect the secondary side, the 230-volt side, of the transformer to this newly installed breaker. The breaker should be correctly sized for the 15 amps load, but consider a slightly higher rating, such as 20 amps, to accommodate any potential inrush current or future load increases, while still adhering to the relevant electrical codes and regulations. Sixthly, run the appropriate gauge and type of 230-volt rated wire from the newly installed 230-volt breaker in the panel to the location where the 230-volt equipment, in this case the sterilizer, will be connected. Connect these wires to the 230-volt outlet. Ensure that you connect the hot, neutral, and ground wires properly to the corresponding terminals on the outlet. After wiring the outlet, install the cover plate to protect the connections and provide a finished look. Seventhly, meticulously verify all electrical connections to ensure they are tight and secure. Loose connections can cause arcing, overheating, and potentially hazardous situations. Use a torque screwdriver to tighten the connections to the manufacturer's specified torque settings to ensure optimal conductivity and prevent loosening over time. Eighthly, once all connections have been verified, carefully power up the 480Y/277-volt three-phase panel. After powering up, test the operation of the 230-volt equipment, in this case the sterilizer, to ensure that it is functioning correctly. Use a multimeter to measure the voltage at the outlet to confirm that it is indeed 230 volts. Check for any unusual noises, vibrations, or smells coming from the transformer or the equipment, which could indicate a problem. Finally, consider these additional factors. The step-down transformer should be appropriately sized for the load, meaning it should be capable of handling at least 15 amps continuously without overheating or experiencing voltage drops. It's often recommended to choose a transformer with a slightly higher rating to provide a safety margin and accommodate any future increases in the load. The existing conduit and wire that were previously used for the 480-volt three-phase 50 amp sterilizer may need to be re-evaluated to ensure that they are properly sized for the new 230-volt 15 ounce load. While the amperage is lower, the wire gauge must still be adequate to handle the current without excessive voltage drop or overheating. Consult the National Electrical Code, specifically Table 310.15, to determine the appropriate wire size based on the ampacity, insulation type, and installation method. It is strongly recommended to consult with a licensed electrician to ensure that the entire installation is done safely and in compliance with all applicable electrical codes and regulations. Electrical work can be dangerous, and improper installation can lead to serious injury, fire, or equipment damage. A licensed electrician has the knowledge, skills, and experience to perform the work safely and correctly. The electrician can also verify that the existing electrical system is adequate to handle the new load and make any necessary upgrades or modifications to ensure safe and reliable operation. Remember that working with electrical systems can be dangerous, and it's essential to take all necessary precautions to protect yourself and others from harm. Always de-energize circuits before working on them, use properly insulated tools, and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, it's best to leave the work to a qualified professional. Consider the transformer's wiring configuration. Depending on the specific transformer you select, it might have different wiring configurations on the primary and secondary sides. Some transformers may require a specific grounding configuration to ensure proper operation and safety. Pay close attention to the manufacturer's instructions and wiring diagrams when making connections. Also, consider the inrush current when selecting the branch circuit breaker. Some equipment, particularly those with motors or transformers, can draw significantly higher current when first turned on than during normal operation. This inrush current can trip a circuit breaker that is not properly sized to handle it. Select a breaker with an appropriate time delay characteristic to accommodate the inrush current without nuisance tripping. Furthermore, ensure proper ventilation for the transformer. Transformers generate heat during operation, and it's important to provide adequate ventilation to prevent overheating. Mount the transformer in a location where there is sufficient airflow to dissipate the heat. Avoid enclosing the transformer in a small, unventilated space, which can lead to overheating and premature failure. Consider the environmental conditions. If the transformer is to be installed in a harsh environment, such as one with high humidity, extreme temperatures, or corrosive substances, select a transformer that is specifically designed for those conditions. Look for transformers with appropriate environmental ratings, such as NEMA 3R or NEMA 4X, to ensure that they can withstand the elements. Also, make sure all electrical boxes, conduit, and other materials are rated for the environment as well. Furthermore, check for any local codes or regulations that may apply to the installation. Some jurisdictions may have specific requirements for electrical installations, such as the type of wiring methods allowed, the location of outlets, or the use of specific types of equipment. Be sure to comply with all applicable codes and regulations to ensure that the installation is safe and legal. Also, document the installation thoroughly. Keep detailed records of all work performed, including wiring diagrams, equipment specifications, and test results. This documentation can be helpful for future maintenance, troubleshooting, or modifications to the electrical system. Use wire labels to identify all conductors. This can help prevent confusion during future maintenance or troubleshooting. Clearly label each wire with its function, such as hot, neutral, or ground, and its circuit number. This will make it easier to trace circuits and identify potential problems. Consider using a surge protector on the 230-volt circuit. Surges and voltage spikes can damage sensitive electronic equipment. A surge protector can help protect the sterilizer from these damaging events. Choose a surge protector that is specifically designed for 230-volt circuits and has an appropriate surge current rating. Furthermore, after completing the installation, thoroughly test the circuit to ensure that it is working properly. Use a multimeter to measure the voltage, current, and resistance of the circuit. Check for any shorts, grounds, or open circuits. Also, verify that the equipment is operating correctly and that there are no signs of overheating or other problems. Finally, provide proper training to the personnel who will be operating and maintaining the equipment. Make sure they understand the proper operating procedures, safety precautions, and emergency procedures. This will help ensure that the equipment is operated safely and efficiently, and that any potential problems are identified and addressed promptly. If the sterilizer is using a GFCI outlet, ensure you test the outlet after installation to verify it is working to protect any users. This is typically done by pressing the test button on the outlet itself. Be mindful of the load calculations. When adding the new 230-volt load to the existing electrical system, it's important to perform load calculations to ensure that the panel and the service are not overloaded. The National Electrical Code, specifically Article 220, provides detailed guidelines for calculating electrical loads. Take into account all existing loads in the panel, as well as the new 230-volt load, to determine the total demand. If the load calculations indicate that the panel or the service is overloaded, it may be necessary to upgrade the electrical system to accommodate the new load. When selecting the transformer, consider its efficiency. Transformers are not 100% efficient, and some energy is lost in the form of heat during operation. Choose a transformer with a high efficiency rating to minimize energy losses and reduce operating costs. High-efficiency transformers typically have low or no load losses and lower full load losses than standard efficiency transformers. This can result in significant energy savings over the life of the transformer. Also, consider the transformer's impedance. The impedance of a transformer affects its ability to regulate voltage under load. A transformer with a low impedance will have better voltage regulation than a transformer with a high impedance. This means that the voltage on the secondary side of the transformer will remain more stable even when the load changes. For sensitive equipment, it's important to choose a transformer with an appropriate impedance to ensure stable voltage and reliable operation. When installing the conduit, ensure that it is properly supported and secured. Conduit should be supported at intervals specified by the National Electrical Code, typically every 3 to 10 feet, depending on the size and type of conduit. Use appropriate conduit hangers, straps, or clamps to secure the conduit to the building structure. This will prevent the conduit from sagging, vibrating, or becoming damaged, which could compromise the integrity of the electrical system. Finally, when making wire connections, use only approved connectors and tools. The National Electrical Code requires that all wire connections be made with connectors that are listed and labeled for the specific application. Use the correct type of connector for the size and type of wire being used. Also, use the appropriate tools for crimping or tightening the connectors. This will ensure that the connections are secure and reliable, and that they will not loosen or corrode over time. Check the nameplate of the transformer and the sterilizer. The nameplate provides critical information such as voltage, phase, frequency, and power ratings. Verify the information on the nameplates against the system requirements and make sure that the equipment is compatible with the electrical system. Furthermore, consider the impact on power quality. The addition of a transformer and a new load can affect the power quality of the electrical system. This can cause voltage fluctuations, harmonic distortion, and other power quality problems. Use a power quality analyzer to measure the voltage, current, and frequency of the electrical system before and after the installation. This will help identify any power quality problems and allow you to take corrective action. If you are using flexible conduit, ensure it is properly grounded. Flexible conduit is often used in electrical installations to provide flexibility and ease of installation. However, flexible conduit is not always a reliable grounding path. Therefore, it's important to ensure that flexible conduit is properly grounded by using a separate grounding conductor. Connect the grounding conductor to the conduit at both ends and to the equipment grounding terminal. This will provide a low impedance grounding path and help protect against electrical shock. Consider the use of a ground fault circuit interrupter, or GFCI, for the 230-volt circuit. A GFCI is a device that detects ground faults and interrupts the circuit to prevent electrical shock. GFCI protection is required in many locations, such as bathrooms, kitchens, and outdoor areas. Consider using a GFCI for the 230-volt circuit to provide additional protection against electrical shock. Always consult the latest edition of the National Electrical Code, or NEC, for the most up-to-date requirements and recommendations for electrical installations. The NEC is a comprehensive set of standards and guidelines for electrical safety. It is important to follow the NEC to ensure that the electrical installation is safe and compliant. Always remember that electrical work is dangerous and should only be performed by qualified personnel. If you are not comfortable working with electricity, it's best to leave the work to a licensed electrician. A licensed electrician has the knowledge, skills, and experience to perform the work safely and correctly.